Alright guys, today's goal, integers and exponents and integer exponents and scientific notation. Okay, so here's the thing. Look at these two. These look the same, but these two are totally different problems. This one here is -1 times 5 squared. This one is just -5 times -5. So this one's positive 25, this one is negative 25, okay? Anytime you're using an exponent, make sure you use parentheses when you see a negative in the parentheses. See how right here the negative is inside the parentheses? That means you need to do this. If it's outside the parentheses, you can just enter it. Okay, or if it's outside, do this. Okay? So this would be -3 to the third, which is -27. The next one, you'd still enter the exact same way, but it's still going to be -27 because it's -3 times -3 times -3. Okay? Now here's some exponent rules that we're going to need to remember. Okay? Product rule. See how you have the base is the same, so what do you do with the exponents? You add them. When you have a power to a power, it's multiply. When it's division, you subtract. Or when it's a fraction to an exponent, you distribute it to both the top and the bottom. Anything to the 0 power is 1, and anything to the first power is itself. So let's take a look at some examples here. Okay? So here it says, apply the rule of the exponents. So you need to, that'd be 4 to the 2 plus 3, which is 4 to the 5th. A to the 3 plus 15, which is A to the 18th. Now, for this first one, plug it into your calculator, hit 4 to the 5th, calculate. Okay, here. So, you have 4 and you have 3, so multiply those first, so you get 12. And it'd be B to the 2 plus 3, which is 12B to the 5th. Power to a power, you multiply, so this would be B to the 3 times 5, which is B to the 15th. Okay, let's keep going. Here we have 4B to the third. So this is where we got to be careful. That's 4 to the first. So you have 4 to the 1 times 4, B to the 3 times 4. So this would be 4 to the 4th, B to the 12th. Most common written wrong answer. They forget to put the 1 right here. And so they don't distribute that exponent to the 4. Okay? So be careful. Let's look at a couple more. So division. This one, now, here's the thing. This is what I do. Identify where's the larger exponent. Well, it's on the top. So you know the variable is going to end up on the top. So you have A to the 15 minus 4. And that is A to the 9th. Okay, or 11th. Now let's say we flip that. And this is what I'm talking about. If you do the subtraction rule, it's 4 minus 15 because it's always top minus the bottom. That's A to the -9th, which we're going to be getting into this. But you can't have that positive. So see, you can't have a negative exponent, so you got to move it down. So it's A to the 9th, or 1 over A to the 9th, because you got to move it to the bottom. See, what I would do here when you see this is I say, see how the exponent is larger on the bottom? That means it's going to end up on the bottom and not 15 anymore. But that means it's going to end up on the bottom. So I have this. Well, what's 15 minus 4? 9. Okay, we'll see some more examples of this. But here we'd have A to the 5th, B to the 5th. Okay? All right, let's look at some more. So we're still just simplifying using the rules of the exponents. So what do we have here? This would be m to the 4 plus 3 plus 5, which is m to the 12th. Here you have negative 4 to the 2 plus 5 times 3 to the 7th, which would be negative 4 to the 7th times 3 to the 7th. Okay? Now hold on. Get out your calculators and try to calculate this now. Okay? So we have options here. See how the exponents are the same but the numbers aren't? Well, you could enter this all into your calculator, or since the exponent is the same, what's negative 4 times 3? You can enter just that into your calculator, and you would get negative 358311808. Okay? So let's look at another one down here now. Okay, so here we have 1 and 1. Okay, so now we look. 2 minus 1 is 1. Where's the larger? The top. So A is on the top, and it's A to the first. Okay. The B, 3 minus 1 is 2. Where's the larger? On the top. So it's B squared. So it's just AB squared. Okay. Now this next one here. What I would do, you can do it two ways, but I'm going to show you one. So what I would do here is to simplify everything inside first. So I see this at blank, which means 1. So this would be A to the second, because 4 minus 2 is 2. And the large is on top, so it stays on top. B to the 4 minus 3 is just B. C to the 4 minus 1 is C to the third. And then power to a power, what do? We multiply. 2 times 2, 4. B to the 1 times 2 is 2. C to the 3 times 2 is 6. Now the other way, I guess I'll show you, that you could do everything is you could distribute this to all of it first, okay? So don't forget to give this a 1. So you'd have A to the 8th, B to the 8th, C to the 8th. Because remember, 4 times 2, 4 times 2, 4 times 2. So here we have 2 times 2, 3 times 2, 1 times 2. So you have A to the 4th, B to the 6th, C to the 2nd. Now, what's 8 minus 4? 4. What's 8 minus 6? 2. 8 minus 2, 6. So see, that's the same answer that we got up there. Okay, let's take a look at some more. Alright, again, don't forget to put the exponent with the number. So this would be 3 squared x squared y squared z squared, which is 9x squared y squared z squared. See, look at the difference. See how here the number's outside? That means not to the third. Inside, it is to the second. Okay? So this is just 5, t to the third, r to the third, s to the third. So here we have that to the first. So you have 6 times 2 to the third, m to the, what's power to a power? Remember, you multiply. So 2 times 3, 6, p to the 12th. Now, 2 to the third is 8 times 6 is 48, so you have 48. M to the 6th, P to the 12th. Okay? Let's take a look at some more. Alright, so if we look, what's the difference between these two? Here you're adding, here you're multiplying. When you add, it's just how many x to the thirds do you have? So this would be 13x to the third. But now here, what's 5 times 8? 40. And then what's x to the third times x to the third? Well, remember you add, so 3 plus 3, 6. Okay, so this one we still have the negative. That'd be 2 squared a squared over 3 squared y squared. So you get negative 4a squared over 9y squared. Hopefully we're remembering doing these previous years. Okay. What do you do when you have a power to a power? Multiply. So it's 3 to the 4th, m to the 8th, 5 to the 4th, t to the 16th. Okay. So that equals 81 m to the 8th over, I believe, 625 t to the 16th. Let me check here. Yep. Okay. Let's take a look at another. Alright. So here, first thing we got to do is simplify this one and simplify this one. So keep it in parentheses. So here we'd have 2 to the 4th, x to the 8th, y to the 12th, times 3 to the 3rd, x to the 3rd, y to the 6th. Okay? And then that would be 16 x to the 8th, y to the 12th, times 27 x to the 3rd, y to the 6th. Okay, so then we do 16 times 27, 432, x, and then remember, x to the 8th times x to the 3rd, you add 8 plus 3, 11, y to the 18th. Okay, let's take a look some more here. Alright, what's anything to the 0 power? 1. What's anything to the first power? X. Here, though, this one's tricky, because can you divide by 0? No. So the answer to this, undefined. Now here, this is where we got to remember, this is negative times x to the 0, so that's negative 1. Okay? So let's take a look at some more. Alright, so now we're dealing with negative exponents. Okay? So simplify completely. You have 5 to the negative 2, so if I put it over 1, it means I got to move it to the bottom. So that's 1 over 5 squared, which is 1 over 25. If I put this over 1 and move it down, I get 1 over 0 squared, which is 1 over 0, which is undefined. Because you can't divide by 0. Now when it's a fraction, watch what I do. See how I just flipped it and it made it positive? That's when you have a fraction. That's what you can do. You flip the whole fraction, take the reciprocal, and it changes the exponent from negative to positive. So this would be 2 squared over 1 squared, which is 4. Because when you divide by 1, it goes away. Okay? I would never, ever, 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 ever do this one, but this would be 1 to the negative 2, 2 to the negative 2. Well, to make this positive, I move it up. To make this positive, I move it down. So you still get the 4. The only thing we need to know is if it's in the bottom, to make it positive, move it up. If it's in the top and it's negative, to make it positive, you move it down. Okay? So 4/5 to the negative 2 means 5/4 squared. So that would be 25 over 16, because 5 squared 25, 4 squared 16. Okay? We need to be able to show this work on tests and quizzes, not just use the calculator. Alright, so here, remember what I said. It's negative. To make it positive, I move it down. So I have 4 squared. The b is positive, so I keep it there. The y is negative, so I move it down. Okay? So I'm done with the top. Now I go to the bottom. The 5 is negative, move it up. The D is positive, keep it there. The C is negative, move it up. So I get 25bc squared over 16dy to the third, because you should always try to do alphabetical. Is there any like terms I can combine? No. Okay. So next one. This one looks a little trickier than it is, so let's just talk about the exponent rules here. The 3, see how it's not to the negative 2, so that means you're keeping it there. Now I'm going to make this positive before I do anything. So this negative move down. So that means m plus n squared is down. This negative 4 move up. That means m plus n moves up. So this would now, this is where we think. See how we have 4 on top, 2 on the bottom? The larger's on top. What's 4 minus 2? It's 2. So this is 3 m plus n squared. And we can leave it there. Okay? Let's keep going. Okay. So, first thing I would do, since both of these are negative, I would just distribute. Okay, so this would be, we have x, what's negative 1 times negative 2? Positive. And then this would be negative 4z to the negative 2. On the bottom you'd have x to the positive 3, y to the negative 3, z to the negative 1. Now I'd go and make them positive. So the x's are, didn't mean to do that. So the x's are both positive. So those just stay there. Okay. Now this y is negative, so move it down, and this y is negative, so move it up. So they're going to switch. So this is going to be y to the third, y to the fourth. And the z's are both negative, so z to the first, z to the second. Now we can try to subtract them, but this is what I'm talking about. Okay? If I look at the x's, where's the larger exponent? It's in the bottom. So what's 3 minus 2? It's 1, but it's got to go to the bottom. 4 minus 3 is 1, but where is the larger one? In the bottom for the y. So the y is on the bottom. Same with the z. 2 minus 1 is 1. See how you left the top blank? It's not a 0. It means put a 1 there. And there's your answer. Okay? Alright. Let's do some more. Alright, now we're on to the scientific notation part. It's saying I want you to write it in standard notation. So I copy it down. And see how it says times 10 to the 8th there? So that means move it 1, 2, 3, 4, 5, 6, 7, 8. Fill in with zeros. And there's your decimal. So this would be 5, 4, 3. And then comma, comma. Now, the negative 8 one, that means leave some space to move backwards. So you go 1, 2, 3, 4, 5, 6, 7, 8. And then you got to fill in with zeros. And then there's another 0 there. So this would be 0.1, 2, 3, 4, 5, 6, 7. Okay. So see how this number is bigger than 1 at the end result, and it was a positive exponent. This number is smaller than 1, and it's a negative exponent. So see how this number is bigger than 1? That means we're going to have to end up with a positive exponent. So what we need to do is count. We need to get the number between 1 and 10. Okay, so 1, so we have to move this decimal back. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Now I'm looking there. I'm at 569.3. That's not between 1 and 10. How about 56.9? Not between 1 and 10. How about 5.693? Yes. So now we have to count again. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So you have 5.693 times 10 to the 19th. Double check just by counting the numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So again, same thing here. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I think it's going to be 18, but it might be negative 19, so we'll see. This is where it helps to move. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. See, 17 puts me there, but that's 0.15. I need one more. So that's 1.5 times 10 to the negative 18th, because that number is smaller than 1. Okay, so there's basic scientific notations. Okay? Now, to do math with the scientific notations, watch what we do here. So, see how you have 7 and the 5 and it's multiplication? So do 7 times 5, 35. Times 10, and then see how they have 10 and 10? They're the same base, so what do we do with the exponents? We add. So that would be to the 7th. But now, we got to back this up 1, which means add 1. So you get 3.5 times 10 to the 8th. Okay? So if we look at this one, you have 14 divided by 7 is 2, and then subtract. This just subtract, top minus bottom, so it's times 10 to the 2nd. Okay? Doesn't matter. You don't have to worry about where positive, negative, because you can have negative exponents for scientific notation. So this one, first thing we got to do is change them to scientific notation. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 7.2 times 10 to the 10th. Divided by, and then 1, 2, 3, 4. 1.2 times 10 to the negative 4th. So do 7.2 divided by 1.2. You get 6. Times 10 to the 10 minus negative 4. So that'd be 6 times 10 to the 14th. Is that number between 1 and 10? Yes. So we're good. Okay, let's take a look at some more. Everybody's favorite, the word problems. It says on March 16, 2006, Congress raised the government's debt limit to $9, or to $9 times 10 to the 12th. When the national debt limit is reached, about how much will it be for every man, woman, and child in the U.S. country? Use 300 million as the population. So we want dollar amount per person, so we're going to say X. So the equation is X equals, well, you have 9 times 10 to the 12th divided by, well, 300 million. So that's 300 million. So that would be 1, 2, 3, 4, 5, 6, 7, 8. 3 times 10 to the 8th. 9 divided by 3 is 3. 12 minus 8 is 4. So it's 3 times 10 to the 4th. But that makes no sense to me, so I would just go 3 times 10 to the 4th. 1, 2, 3, 4. So $30,000 for every American. Okay? We'll see you guys in class.